Hi everyone, today we're going to start a new topic. It's all about the measures of central tendency and the measures of dispersion. Let's start with the first one, which includes the mean, the median, and the mode. Okay, so the mean is the average. How do you calculate it? We just add all of the values and then divide by their number. We have this symbol represents the mean, and this one means sigma, and it's the sum of all values, and then we divide by their number. Okay, so we add all of the values and then we divide by their number. So we have 1, 2, 3, and 4. So we have 4 values. We divide by it and we get the mean. Then we have the median. The median is the middle value. We have to organize the values from the lowest to the highest, and we already have them. It's 1, 1, 2, 4, and 8. We cancel these and we end up with 2, and the median is 2. Okay, we have another example. We have to organize them, so it will be 2, 3, 4, and 6. Okay, so we have, in this example, we have 5 values. It's an odd number. That's why we have 1 middle value. But here we have 4 values, so there are 2 middle values. How do we calculate the median? We just add them and divide by 2, and we'll get 3.5. Okay, so how do we know, like, what's the position of the median? The number of the value that contains the median. Okay, let's have an example. If we have these values, how do we know that where is the median exactly after organizing them? We just use this formula. For example, here the median is the third value. How do we know this? It's the third or the second or the fifth. How do we know this? We use this formula. So it's n plus 1 over 2. N is the number for all values. So we have 1, 2, 3, 4, 5. We have 5 plus 1 over 2, which is 3. So it's the third value. And take another example. If we have these values, 1, 2, 3, 4, and 5. Okay, so the median here is 3. How do we get this? We have 1, 2, 3, 4, and 5. 5 plus 1 over 2, again the same thing. It will be 3, so the median is the third value, which is 3. Okay, if we have the mode, what's the mode? It's the most repeated value. For example, here 1 is repeated. It's written twice, so the mode is 1. But here we have 2 modes. We have 1 is repeated twice and 2 is repeated twice as well. So we say that the modes are 1 and 2, and this is bimodal. If you have to graph it, it will be, if it's of course normally distributed, it will be like this, bimodal. Okay, and in this example we don't have mode because there is no any repeated value, so no mode. Now we go to the measures of dispersion. What do you mean? It means variability or the spread. Okay, so we have the range, variance, standard deviation, percentile, interquartile range, and outliers. And we're going to see the graphs here. I'm gonna leave it till the end of the video. Okay, so the range is the maximum value minus the minimum value. Okay, for example, if we take this example, the range will be 5 minus 1, which is 4. Highest minus the lowest. Okay, and the variance is symbolized by s squared, and s squared is equal to sum of all values minus the mean squared over n minus 1. Standard deviation is just the root of the variance, and this is its symbol, or just s. Both are correct, and we take the root of this rule. It's the same thing. Okay, so for example, if we have these values, how do you calculate the standard deviation? We just take root of, okay, what's the mean here? 1 plus 2 plus 3 plus 4 plus 5 equals, divided by 5. It's 3. Okay, so it will be 1 minus 3 squared plus 2 minus 3 squared plus 3 minus 3 squared, which is 0, plus 4 minus 3 squared plus 5 minus 3 squared over n minus 1, which is 4. And then we just get the answer, and this is the standard deviation. If you want the variance, you don't take the square root, you just use this formula. Okay, now we go to the percentiles. What's the percentile? Percentile is like a value that divides the data. For example, if you say we have, this is the whole data, and we have the 25th percentile, we mean that 25% of the values lie below this value, and it's called Q1. Okay, if we have 50th percentile, we mean 50% of the values lie below this value, which is Q2, which is the median. And for the 75th percentile, it's Q3, and the same interpretation for it as well. For example, if you have the 25th percentile, 25% of the values lie below it. Okay, and the interquartile range, IQR, this is the symbol. What is IQR? IQR is equal to Q3, okay, this value, minus Q1, minus this one. Okay, so for example, if we have 1, 4, 6, and 10, then 11, this is Q2, okay, and if we have, for example, here 0.5, and if we have 12, okay, this will be Q2, this will be Q1, and this will be 11. Okay, let me repeat it. If you have 0.5, 1, 4, 6, 10, 11, and 12, how do you calculate it? Okay, it's organized, so we just cross these out, and this is Q2, which is the median. Okay, then how do we calculate Q1 and Q3? If it's an odd value like this one, like the values are odd, we have how many values? 1, 2, 3, 4, 5, 6, and 7. So it's an odd number, so we don't consider the median. The median is outside. We consider these as a whole group, and these as one group. And here, where is the middle value? It's 1, so this is Q1. Here, where is the middle value? It's 11, so it's Q3. Now, what is the interquartile range, which is Q3 minus Q1? It will be 11 minus 1, which is 10. Okay. What if we have, let me delete these. What if we have even numbers? Like here in this example, we had 7 values. Now, if we have 1, 4, 6, 10, 11, and 12, we have 6 values. Okay. We'll take these two to calculate the median. It will be 8. It's 16 over 2. Okay, now we'll consider these two when we divide the data into 2, because we cannot like separate them, cannot exclude them. Only if it's an odd number, we exclude the median. If there are 2 values and we take the average of them, no, we include them in Q1 and Q3. Keep this in mind, okay? And this will be Q1, and this will be Q3. Here 11 minus 4. Okay, and this is the answer. We'll get it. It's 8, sorry. Okay. that's all. Okay. Outliers, we have abnormal observations. Okay, to decide whether a value is an outlier or not, we use this equation. For the lower outlier, we say Q1 minus 1.5 times interquartile range, and for the higher, Q3 plus 1.5 times IQR. Okay, for the lower, we say Q1 minus, this is a fixed number, it's 1.5 times IQR. And for Q3, we add 1.5 times IQR. So this is fixed. We just change these two. Okay, we're going to solve for the outliers. First, we organize the values. It will be 2, 8, 12, 7, 15, 17, 102. Okay, so we want Q1 and Q3 in order to use these two equations and to decide which value or values like will be outliers. Okay, so for the median, these two will be the median, so we'll just divide them by 2. The median, which is Q2, is 13.5. And then we'll include this one and this one. This is Q1, it's 8, and here it's 17. Okay, so IQR will be 17 minus 8, which is 9. And for the outliers, for the lower one, it's equal to Q1, which is 8, minus 1.5 times 9, which is the IQR. And then for the higher one, we have 17 plus 1.5 times 9. Okay, so we'll see. It will be negative 55. So any value that lies below negative 55, it's an outlier. So no lower outlier in this example. What about the higher one? We'll just change 17 and plus. It will be 30.5. So 102 is an outlier. Okay, we'll have these two graphs. If you have this graph and this graph, okay, so we will delete it. Try again. Which one has more variability, A or B? Well, A has more variability. Why is that? Because A is more spread. Okay, but this one is narrower, this one is wider, so A is like more spread. Okay, I just wanted to highlight this point, and that's the end for this video. Thank you for watching.